So what's up guys? My name is Ywh and I'm going to talk about question 5 for our CBT test this time. So, two discrete random variables x and y are jointly distributed over a series of points. The joint probability mass function is 1 over 66. Okay, we are given x equals to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But our y only range from 0 to x. So why is this so? This means our y cannot be larger than x. Okay, let me give you an example. So when x equals to y, our y can be 0, can be 1, can be 2, can be 3, can be 4, and can be 5, but cannot be 6, 7, 8, 9, 10 because it is larger than x. So we cannot allow that to happen. So here is the graph I have plotted. There are 66 total combinations. I'll try to make sense of this 66 combination for you later in our next part. Alright, let's jump into the question. Roman 1. So compute coefficient of variation. What is coefficient of variation? Coefficient of variation is a statistical measure of the dispersion of data points in a data series around the mean. So Roman 2, compute probability of x larger or equals to 4. And then for third, compute probability of y larger than 7 given that x larger or equals to 8. So here is another graph I've plotted for you. So we have x range from 0 to 10 and y range from 0 to 10 as well. So remember our probability mass function, 1 over 66. So, and remember also our condition, y cannot be larger than x. So we just fill in 1 over 66 for each of the cells that fulfill the condition that y is not larger than x. So let me explain further. So let's say when x equals to 1, y equals to 5. I didn't fill in anything. That means it doesn't fulfill the condition. So if you add everything up, you will get 1, which actually tells you that we have fulfilled everything and we are on the right track because we get 1 as everything. Alright, Roman 1, correlation of variation, we need to find it. So since the question didn't really specify they want x or they want y, so why not we do both of it? So explain the formula again. Correlation of variation is sigma over mu. So what is sigma? Sigma is standard deviation. What is mu? Mu is expectation. So let's start with expectation since we can get sigma from our expectation as well. So expectation of x. So we just copy everything, the data we have here, and form another new table here. Alright, now we need to get the probability of x. So probability of x equals to 0 is easy. We just sum everything that is available on the column. So we do the same thing for 1. Sum everything here. You will get 1 over 33. Same thing for the 2. You will get 1 over 22. So do the same thing for the rest. Next, we are going to fulfill the condition required by the expectation, which is x times p probability of x. So we are going to find x times probability of x. So how do we find it? It's actually easy. We just use the x, c22, and then multiply by d22. And then we will get our x times probability of x. So do the same thing for the rest. You will get, and add everything up together, you will get 6.67. And then now we are going to find the second moment. So second moment, we need to use square of x. So how do we use square of x? We need to use this thing, which is the hat. Alright, so insert the formula, do the same thing, x hat 2, and then multiply by this probability, sum everything up, you will get 51.67. Alright, and then variance of x, the formula of variance of x is actually second moment minus the square of first moment. So if you do the calculation yourself, you will get 7.22222. So variance is not the thing we want. Actually, we are not interested in variance. We actually want the standard deviation. So standard deviation is actually square root of variance. So we just, in order to find correlation of variation, just use the standard deviation, divide by the expectation. You will get 0.403. That is the correlation of variation for X. Now, let's jump to correlation of variation for Y. It's actually the same thing, but there's a slight difference. So, okay, so just do the same thing, copy from 0 to 10. Okay, and then we are going to find probability of Y when it is 0. So we just add everything up in this row. So we get 1 over 6. So do the same thing for when Y equals to 1. You get 5 over 33. So do the same thing for the rest. So we are going to fulfill the requirement of expectation of Y. So it's actually Y times probability of Y. So do the same thing for the rest. You will get 3.333. And then we are going to find second moment. How do we find second moment again? We need to add 2. So our Y has to be add 2, which is 0 square times probability of Y equals to 0, which is 1 over 6. You will get 0 as well. But you do the same for the rest of the numbers, and then you add everything up, you get 18.33333. For variance, do the same thing, 18.33333 minus square of 3.33333, you will get 7.22222. For standard deviation, as what I said just now, standard deviation is square root of variance Y. So you will get 2.687. So correlation of variation for Y, 2.687 divided by 3.33. You will get 0.8022577. Alright, Roman 2, Px larger or equals to 4. So we can actually find the complement of it, which is 1 minus x smaller than 4. So how do we get P probability of x smaller than 4? It's actually quite easy. We just, since we have the data from here just now, we can actually just copy it down here to make it more neater and it won't confuse you. So P's probability of x smaller than 4 is actually probability of x equals to 0, probability of x equals to 1, probability of x equals to 2, probability of x equals to 3, but probability of 4 is not included because it's smaller than 0. Sorry, smaller than 4. Alright, so we just 1 minus the sum of all of this, you will get 28.33. Alright, Roman 3, last Roman. So we need to find probability of Y larger than 7 given that x larger or equals to 8. So we can actually break down this conditional probability into joint divided by marginal. So our joint is probability of Y larger than 7, x larger than 8. Marginal is probability of x larger than 8. Larger or equals than 8. Sorry, my bad. Alright, and then let's make everything simple. We start by doing probability of x larger than 8. So let's go refer back here. Probability of x, and then we just find probability x larger or equals to 8. So 8 is included, 9 is included, 10 is included. So we just sum the probability of these three. So 3 over 22, 5 over 33, 1 over 6. At the end, we will get 5 over 11. Alright, next part we'll go to the join. So probability of y larger than 7, x larger or equals to 8. So it's actually here, y larger than 7. So larger than 7, so 7 is not included. So we start from 8, 9, and 10. So we just sum these three up. 1 over 22, 1 over 33, 1 over 66. We'll get 1 over 11. But there is actually another way of looking at it. So let me show you. So probability of y larger than 7. So larger than 7. 7 is not included. And then probability of x larger or equals to 8. So 8 is included. So it's everything here. Everything that I have highlighted here. So there are 1, 2, 3, 4, 5, 6. So 6 over 66 will get 1 over 11. Is it the same as what we did? Yes, it's the same. So let's find the final answer. Probability y larger than 7, given that x larger or equals to 8. So we just use our joint divided by our marginal. So we'll get 1 over 5. So that's it from me. See you guys soon.